Let's see another example on how we can find the absolute maximum and minimum of the function f of x comma y that is equal to 2x to the third plus y to the fourth on the set of points x comma y where x squared plus y squared is less or equal to 1. First of all, before seeing what happens on the set D, we need to find the critical values of the function. And in order to do that, we'll have to find the partial derivative of f with respect to x, which is just 2 times 3 times x to the square, so 6x to the square. And setting that f of x to be equal to 0, we get that 6x to the square is equal to 0, so that means that x equals to 0. And then for the fy, we have that this is equal to 4y to the third, and setting that fy to be equal to 0 gives us that 4y to the third is equal to 0, so that means that y is equal to 0. So we only have one critical point, 0, 0, and the value of the function at that critical point, f0, 0, is equal to just 0. Let us now see what happens in the given boundary that we have. So on the boundary, first of all, let's graph that boundary. So the boundary will be this circle, x squared, this disk actually, x squared plus y squared is less or equal to 1, so we have just a disk. And let's see what happens first of all on the circle x squared plus y squared is equal to 1. So let's see what happens on that circle. And we know that when x is equal to 0, that means that y will be equal to either plus or minus 1. And when when y is equal to 0, then x would be either plus or minus 1. So that gives us 4 points, the points 0, 1, 0, negative 1, and 1, 0, and negative 1, 0. So we need to check the values of the function at those points. So for the points f0, 1, the value of the function is actually the same as the value of the function for the point 0, negative 1, and it's equal to 1. And for the point f, for the point 1, 0, the value of the function is equal to 2. So we said x equals to 1 and y equals to 0 here, so that gives us 2. And then for f, the value of the function f at the point negative 1, 0, this will give us negative 2. Okay, so let's see now what happens on the boundary. So in this case, we start from what happens on the boundary in general. So in this case, we have that x squared plus y squared is equal to 1. And from that, we get that y squared is equal to 1 minus x squared. And substituting that to the function that we have, the f of x comma y, we get that the f of x comma 1 minus x squared, so actually the function f of x comma square root of 1 minus x squared would be equal to 2x to the third, and then we have plus y to the fourth. So essentially we have 1 minus x to the square and all to the fourth. So that gives us 2x to the third plus 1 minus x to the square and all to the square. So that gives us 2x to the third plus 1 minus 2x to the square plus x to the fourth. So if we take the derivative of that with respect to x, that will give us 6x to the square minus 4x plus 4x to the third. And in order to find the critical points here, we need to set that derivative equal to 0. So factoring the 2x from the left side, we have 2x times 3x minus 2 plus 2x to the square is equal to 0. So that it gives us two solutions. So either that 2x is equal to 0 or 3x minus 2 plus 2x to the square is equal to 0. So we have to determine if there are critical points on the boundary by plugging the boundary on the function. So that's what we did now. We did here. We plugged in the boundary at the function. So we plugged in this boundary at our function so that we can determine if there are critical points on the boundary. So that gives us two solutions, that 2x is equal to 0, which means that x is equal to 0, or we have, if we simplify here, we'll have x squared plus 3 halves x minus 1 is equal to 0. And from that, we get either that x equals to 0, or if we factor the second degree polynomial that we have in the denominator, in the second degree polynomial, we'll have x plus 2 times x minus 1/2 is equal to 0. So that gives us either that x is equal to 0, or x is equal to -2, or x is equal to x is equal to 1/2. So we have three values for x. We just now have to plug them on the boundary. So for x equals to 0, if we plug them back, let's first write the boundary. So we'll have that y squared is equal to 1 minus x squared. For x equals to 0, which is our first solution, then that means that y squared is equal to 1. So that means that y is equal to either plus or minus 1. So that gives us 2 points, either 0, 1 and 0, -1. And now the value of the function at the point 0, y will be equal to just the y to the fourth. So we just plug in a 0 at the original function. So we plug in 0 here, so that term becomes 0. So we only have y to the fourth. So that gives us that f of 0, 1 would be equal, so we plug in those points here, the point 0, 1, and that gives us just 1, that this is equal to 1, and the f of 0, -1 will give us again the same thing, that the value of the function is equal to 1. And now if we have x equals to -2, then we don't check that, since it's not a point. This x equals to 2 does not belong on the, so it does not belong on the boundary B, so we don't check that. Now, how about for x equals to 1/2? In that case, y squared will be 1 minus 1/4, so it would be 3/4. So y would be either plus or minus equal to either plus or minus the square root of 3 divided by 2. And the value of the function is the same for 1/2 x and plus or minus square root of 3 over 2. And this is equal to 2 times 1/2 to the third, and then plus or minus square root of 3 over 2 to the fourth. So that would be equal to 1/4 plus 9/16, and this is equal to 13/16. The value of the function at 1, 2, comma, plus or minus square root of 3 over 2 would be equal to 13/16. So checking the all the endpoints that we have here. So we have this also these two, and then so what we get is that so by looking at the values that we have, at the values that we had at the critical values, but also the values at the boundary, we see that the maximum value that we have, so we have here 0, 1, 2, -2, and then we have 1 and 1 and 13/16. We see that the maximum value that we have is the value at f1, 0, so the absolute maximum is the value of f at 1, 0, which is equal to 2, and the absolute minimum, checking again and comparing to find what is the smallest value that we have, we see that the smallest value that we have is the value of the function at the point -1, 0, which is equal to -2. So this -2 is the absolute minimum value of the function. So f at -1, 0, it is equal to -2. So this is the absolute minimum value of the function.